Once you start looking at this, I think it becomes so much fun because there's so many questions you may ask. Like, you might wonder, well, do I have to choose between row group elimination and partition elimination if I have a partitioned column store index? Well, let's take a look. We now are declaring our parameter value, or this is actually a local variable. We are now declaring our local variable with the correct data type of datetime20 that matches the data type in the table. So in this case, we should get successful partition elimination because, oh, thank goodness we remembered the data type correctly this time. I'm going to turn on my actual execution plans, and I'm using statistics.io and statistics time, so I get that row group elimination information as well. In my execution plan, I can look at the properties of the column store index scan. And I can see that because it's an actual plan, hey, I did get partition elimination. I only had to look at 6 partitions. They were partition numbers 51 to 56. I also got that push down predicate magic in here too of the 3.1 million rows. But just like last time, I had to push 819,000 rows over from that delta store to be counted by the hash match. When I look at my statistics.io output on the messages tab, now I see segment reads were 4, segment skipped 0. Again, what it means to say here is row groups. We actually had to read 4 row groups. We skipped 0 row groups. The number of skipped row groups has changed because we eliminated a bunch of partitions. For the partitions who were eliminated, it doesn't even think about the row groups because it's like, oh, we eliminated the partitions. I'm only going to even consider the row groups in the remaining partitions. And then at that point, potentially it could eliminate row groups. In this case, it did not have to. But let's go ahead and edit our query a little bit. What if we only wanted things that were after January 15th? We are now partitioned by year, so we may eliminate some partitions, but we now only want a subset of the data within the remaining partitions. So we've got our actual plans on. When I look at my column store index scan, I used the correct data type, so I was still able to eliminate partitions. I only needed partition 51 to 56. When I look at my information here, the way my data laid out is actually kind of funny. All of my births are actually really close to the beginning of the year. And it's like, oh, I looked at the metadata and I was actually able to skip all 4 of them because we had a huge burst of babies born at the beginning of the year and then it stopped. I'm not very good at distributing my birth dates for my babies. My babies are all born just right away. So I've kind of made the human species be a little weird in my database. So we'll reset that demo, but it is able to use both. It can eliminate partitions and then in the remaining row groups, eliminate row groups when that is applicable. And if we look at our data who came back, it's actually after that date, it's only the babies born in 2016 who we actually got back after that date. So that's great that we can have our partition elimination cake, and we can also eat our row group elimination too. You might wonder, can we get row group elimination on other columns? For example, our non-clustered column store index contains a first name ID column. That column is an integer. And we're going to see something else that's a little weird about these execution plans in here too, when 0 rows is not really equal to 0 rows. So I'm looking at, I want to know the count of babies who have the first name ID of 4. I don't actually know what the first name ID of 4 is. It was just a fun number to throw in there. And my table is partitioned based on birth date. There could be babies born at any time between 1966 and 2015 with the first name ID of 4, right? We can't just eliminate, we're partitioning by a totally different column. We can't just eliminate partitions. But those compressed row groups do have metadata on them about the min and max values in that row group. So potentially we could eliminate row groups depending on how frequent first name ID 4 is. I don't actually know. So let's take a look and see what we get for the count of babies with first name ID 4. Well, it's not a very popular name. There's only 21 babies with that name. And when we look at our execution plan, here's our Columnstore index scan. And I look at the properties, sure enough, it's in batch mode. And our actual partition count is 0. Of course, we weren't able to get partition elimination. That's, again, I think of this as not applicable, but maybe I was able to get row group elimination. We had all 21 rows were done in the local aggregation. None of that first name ID equals 4 was in the delta store. It was all in the compressed Columnstore index. And interesting thing here, actual number of rows is 0. This is what leads to this weird thing you may sometimes see in these execution plans. When we look in the plan, and I highlighted this line, we say, okay, how many rows went into the hash match? 0 rows went into the hash match because all of the rows were counted down in the Columnstore. But then you look at the rows coming out of the hash match. When you highlight the operator coming out of the hash match, it says 1. So you end up with this weird situation in an execution plan where 1 row or 0 rows went in and 1 row came out. And it looks like the hash match at first glance, if you don't look at everything else and know what's going on, you just see a hash match operator who had 0 rows go in, but magically 1 row go out. And you're like, did you just make it up? Like, did you just conjure this row from nowhere? Well, what actually happened is we counted all 21 rows in the Columnstore index using that magic counting it can push down. And it's sort of like SQL Server is kind of trying to say that they don't have to be counted by the hash match aggregator. So it's kind of like there's this secret curved line that just sort of joins up with it and goes out of it. Because it's trying to say, I mean, it is fair. The hash match operator doesn't have to count that row, or the 21. It was already counted in there, right? And now I have this crazy drawing on the screen. So you may have cases, because this arrow only shows, the arrow going into the hash match operator, because it only shows how many rows the hash match operator is actually going to have to count. And in our case, it doesn't have to count any. You may end up with seeing 0 rows go into something like that and then 1 row come out. It does have a meaning. It's just a little weird. Well, okay, were we able to actually, that was the other question we had about this was, were we able to get row group elimination on first name ID? I almost said segment elimination because of the weird naming thing, right? But it should be row group elimination. Well, we were able to. It had to read from 6 row groups of compressed segments. It was able to skip 228 of them just by the magic of looking at the metadata. Very, very cool. How about other columns, though? What about state code? Well, a little bit of a spoiler. We currently do not have row group elimination on string columns. Nico, who writes wonderful materials about Columnstore indexes and shows many of the wonders and really cool thing Columnstore indexes can do, Nico has written a blog post about this, and he points out that yes, we would hope to someday have row group elimination on strings, but strings right now are more difficult than Columnstore indexes because they don't have it. And if you think about all the different collations that you could use when storing string data, it's not necessarily a simple thing to code, right? It's not nearly as easy, and I'm not saying any of this is easy, but right, it is a more complex case to provide row group elimination for that. We will see, I'm running this query for just everybody in Oregon. I have a care2 field for state code. And since that is a string column, when we look at this, we were not able to skip any of the row groups. We had to look at them all. Now, our query still was pretty fast. It turns out we have, let's throw some commas in here. We have 1.6 million babies from Oregon. And when, of course, we were not able to do partition elimination We are partitioned on a totally different column, but we get that weird, actual partition count is 0 because we're looking at a non-clustered column store index. But it was able to work that local aggregation magic on it. It only had to push 12,000 rows of those Oregon babies over to be counted by the hash match. So it was still able to do this very, very quickly, even though it didn't get the row group elimination. Another string column is gender. And if I count all the male babies, I see that in that case, I had to look at all the segments as well. Now, that kind of just makes sense. Even if I was able to do elimination, a lot of my segments are going to contain both male and female babies, right? Like there's maybe over 50%, but there's a very high likelihood that a segment is going to contain both male and female babies. So I wouldn't have a great opportunity because of the way my data is laid out when I created my column store index. So segment elimination is a very powerful tool. We are going to get it not for string columns at this point, but even in my case, when I'm doing these aggregations on like counts for string columns, I am still able to get kind of that cool predicate pushdown. Now, there are some limits to what data types and sizes of things we can do when it comes to making things more complex. Check out resources like Nico's blog for that. He also has a great presentation on some of the limitations and the things to look out for. Also, he emphasizes the power of this as well, but as with anything, there are little edge cases and places where the magic may not always be consistent as your use case gets more complex, especially when you have a wide variety of data types in play.